Lesson 313, some final practice. In this lesson, we'll truly bring it all together with everything you have learned about fractions to this point. Not just multiplying and dividing fractions, not just adding and subtracting fractions, not just word problems, not just calculations, but a little bit of all of that. In terms of the word problems, as we always do, it's important to visualize the situation and then ask yourself, what operation is needed? How do I set this problem up in order to solve for what I'm being asked to solve for? Let's get started. Problem 1. Jaya orders printer paper in 2 sizes. The large box has 5 1/5 pounds. The small box holds 1 7/10 pounds less. How much paper does the small box hold? First, visualize the situation. We've got a large box of paper and a small box of paper. We're told how much in terms of pounds the large box holds. Compared to that, we're told the small box holds 1 7/10 pounds less. And we're asked to solve for how much paper the small box holds. What operation are you thinking? If you notice the keyword less and thought subtraction, you're right on. Let's set this up as a subtraction problem. The larger box holds 5 1/5 pounds. The smaller box holds 1 7/10 pounds less. We know when we add or subtract fractions or mixed numbers that we need to start with a common denominator. 5 and 10. What common denominator could work here? Let's test out the larger of the two. If you said that 10 could work as a common denominator, you were right on. So we need to rewrite 1/5 as something over 10. What we do to the bottom, we do to the top. We want to rewrite this mixed number with 10 as a denominator. I need to take 5 and multiply it by 2 to get 10, and I must do the same to the top. Take 1 and multiply by 2 to get 2/10. Subtract out 1 7/10. Are we ready to continue with the subtraction now that we have a common denominator? Not quite yet. Notice that 2/10 is smaller than 1 7/10. So we've got to borrow from the whole. Whole number 5, we take 1 away. That makes this whole number go down to 4. The whole that we borrow from the 5, we add into the 2/10, but we add it in terms of tenths. In other words, this fraction, 2/10, we're going to add a whole on top of it. We're going to add 10/10 to 2/10 and get 12/10. Now, this allows us to continue our subtraction. Let's do our whole numbers first. 4 minus 1 gets us 3. And then our fractions, 12/10 minus 7/10 gets us 5/10. And notice that 5 and 10 both share a greatest common factor of 5. We can rewrite this in simplest form as 1/2 if we divide the top by 5 and divide the bottom by 5. 3.5 pounds is our final. Number 2, Neil won 4 trophies for soccer. He wants to place them in order of height. Heights of the trophies and feet are given below. Order the heights from tallest to shortest. Okay, so to compare or rank fractions, we want to use a common denominator. Look at these different denominators, 3, 6, 2, and 12. The largest of these denominators, of course, is 12. Can 12 work as a common denominator for these other 3 fractions? In other words, can I take these 3 numbers and multiply each of them by something to get 12? If you said yes, you'd be correct. Let's use what we know about equivalent fractions. What we do to the bottom, we do to the top. So if I want to rewrite 2/3 as something over 12, multiply the bottom by 4, Multiply the top by 4. 2/3 becomes 8/12. 5/6. Something over 12. Pardon the focus there. If I multiply the bottom by 2 and multiply the top by 2, this becomes 10/12. 1/2. Something over 12. Multiply the bottom by 6, multiply the top by 6. And then obviously 7/12 already has 12 as a denominator. We're being asked to order these heights from tallest to shortest. 8/12, 10/12, 6/12, 7/12. Well, technically this is the tallest, isn't it? So I'm going to start by my list with 5/6. Next up would be 2/3. Then 7/12. Finally, 1/2, tallest to shortest. Number 3, 3 paper trays hold a weight of 1/3 of a pound. How much paper does each tray hold? So 3 paper trays altogether hold this amount of weight. How much does each individual, how much paper does each individual tray hold? Sounds like division. The total weight shared by the 3 trays is 1/3 of a pound. To find out how much each individual tray does, let's take that and divide by 3. Remember, when we're dividing fractions, let's first rewrite that whole number as itself over 1. And then let's keep what's on the left the same. Let's change the symbol, division to multiplication. Let's flip what's on the right. Multiply across the top, 1 times 1 is 1. Multiply across the bottom, 3 times 3 is 3. 1/9 of a pound. Number 4, if each project requires 1/10 of a pound of paper, how many projects can you get from a 5 1/5 pound box of paper? Let's visualize this. This is how much paper the box contains, and each project will use or require 1/10 of a pound. So, sounds like division. It sounds like we're taking this total amount and dividing it into smaller portions of 1/10 of a pound to see how many projects we can get from it. 5 1/5 divided by 1/10. Okay. So this is a example of something where before we can go ahead with our normal steps, it'll help to convert this mixed number to an improper fraction. Let's do that. 5 1/5. The denominator will stay the same. It'll stay as 5. To calculate the numerator, we'll take the denominator 5 times the big whole number. 5 times 5 is 25. And then add what's on top. 25 plus 1 is 26. 26/5 divided by 1/10. Now let's keep what's on the left the same. Let's change the symbol. Let's flip what's on the right. Do you see an opportunity to use cross-canceling? If you notice the 5 and the 10, you're right on. The greatest common factor that these two numbers share is 5. 5 goes into itself once. 5 goes into 10 2 times. And multiply across the top. 26 times 2 is 52. 1 times 1 is 1. We can get 52 projects out of this box of paper. Next, some calculations. 8 divided by 1/6. We know to rewrite that whole number as itself over 1. We know to keep what's on the left the same, change the symbol, flip what's on the right. and multiply across the top and across the bottom. Oops, I added there. Yikes. 8 times 6, of course, is 48. 2/13 times 2 3/5. Right away, I see we need to convert this mixed number into an improper fraction. Let's do that. The denominator will stay a 5. To calculate the numerator, 5 multiplied by 2 is 10, plus the 3 is 13. Do you see an opportunity to use cross-canceling? The 13s will cancel each other out. 13 goes into itself once. Now multiply across the top. 2 times 1 is 2. Multiply across the bottom. 1 times 5 is 5. We get 2/5. 1/4 plus 5, 6. We need a common denominator. 4 and the 6. 6 is the larger of the two. Will 6 work for 4? No. What's a multiple of 6 that could work for 4? 12. Now let's rewrite both of these as something over 12. What we do to the bottom here, multiply by 3. We do to the top, multiply by 3. 1/4 gets rewritten as 3/12. Here, multiply by 2, multiply by 2. 5, 6 becomes 10/12. When the denominators match, let the numerators do the work. 3 plus 10 is 13. Denominator stays 12. It's improper. 12 goes into 13 one time cleanly, and there's 1 left over, 1 and 1/12. Next problem, 1/9 divided by 8. Let's rewrite that whole number as itself over 1. Let's keep what's on the left the same. Change the symbol. Flip what's on the right. And no cross canceling here, so let's bring it on home. 1 times 1 is 1. 9 times 8 is 72. 2 3/7 minus 1 1/3. Okay, let's think common denominator. 7 and 3. 7 on its own will not work for 3, so let's go through multiples of 7 until we find one that will work for 3. 7, 14, 21. Ding, ding, ding. If you said 21, you were right on. So let's rewrite both of these as something over 21. Over here, 3/7, multiply the bottom by 3, multiply the top by 3. It's rewritten as 9 over 21. Over here, 1/3, multiply the bottom by 7, multiply the top by 7, becomes 7 over 21. Now, we are able to subtract. 9 up here is greater than the 7, so let's subtract whole numbers first. 2 minus 1 is 1. When the denominators match, we'll let the numerators do the work. 9 minus 7 is 2. The denominator remains 21. 1 and 2 over 21 is our answer.